Good evening, Year Nines. So hopefully you coped okay with density and the idea of density and how to measure density. We're going to continue this topic of looking at the structure of matter and the properties of matter by looking in a little bit more detail in the atomic structure of matter. How matter is made up from particles and how the arrangement of the particles contributes to the bulk properties of the material. We've already seen density and how different materials have different densities, and you might be wondering, well, why does iron and lead have a different density? Why does water have a different density from oil, and so on? And it is to do with the arrangement of the particles, the atoms and the molecules which make up the substance. So the next topic we're going to cover today, this is, by the way, going to be the last lesson I'm going to do before half term. I'm not going to give you anything next week. I'll give you a bit of a break. So this lesson will be the last bit of work that I'm going to give you before half term. What we're going to cover today is just going to have a look at solids, liquids and gases, and basically the states of matter and how the atoms are arranged in the three different states of matter, and how that arrangement of the atoms contributes to the overall bulk properties of the material. Now, there is quite a bit of overlap in this with chemistry, so this is something that you probably covered before in chemistry and probably in physics as well at some point in the past. So don't worry about it. It's a bit of a recap. It's never any harm to go over something again to make sure we're clear in our head, because there are a few misconceptions that people sometimes have about the structure of matter and solids, liquids and gases. So that's what we're going to cover today. It's only going to be a fairly short little section. After we get back after half term, we are going to look at the changes of state between solids, liquids and gases, and look at the energies involved in that as well. But today we're just going to look at solids, liquids and gases themselves. Okay, so let's begin. So all substances, or most substances, can occur in the solid phase, the liquid phase and the gaseous phase. The obvious example of that, which you all know about, is ice, liquid water and water vapor. Now, all three of those are the same substance. They're all H2O, they're all water, they're made of the same molecules, but they're in a different state. Okay, so changing from one to another is not a chemical change. We're not changing the substance. It's just a physical change, and it's completely reversible. If we heat ice up from -5 to +5, we know that at 0 degrees centigrade it will change into water, but it could change back again into ice if we took the temperature back down. So what is it about the arrangement of the particles in a material that determines whether it's a solid, liquid or a gas? So I've pulled together a few little demonstrations. Needs must. I'm not in the physics lab at school, so I've had to raid my wife's cupboard, and I've managed to get her baking beads. So I'm using baking beads as a example of or a demonstration of how atoms or molecules, particles are arranged in the different materials and how that contributes to the different properties of the material. So I'm going to start with solids. Okay, so in a solid, the particles are packed closely together, they're bonded together, and they're arranged in a regular pattern. So what I've got here, let me just bring it in, is I've made a nice crystal from my wife's baking beads, and I've attached the baking beads together using blue tack. Okay. Now the blue tack, if you like, represents the bonds between the particles, which are actually electric forces between the particles that are holding the particles together. But what you can see about this, first of all, it's very dense because the particles are close together. So solids tend to be the densest state that any substance can be in. If it's in a solid state, it's usually very dense. There are a couple of exceptions to that, but generally speaking. So first of all, it's very dense. The particles are closely packed together. The other thing is that solid keeps its shape. I mean, obviously, if I just stick this on here, it stays as a pyramid. Okay, that's because the particles are not moving relative to each other, or they're not sliding past each other. The particles can vibrate. Okay, we're not showing that in this demonstration, but the individual particles can vibrate about their position. Okay, and the hotter the material is, the more they will vibrate. But they can't move and shift positions and swap places with each other. They are fixed at that position. They can just move backwards and forwards around that position. All they can do is vibrate. So properties of a solid then, it's dense because the particles are closely packed together. All the particles are bonded to each other. A solid keeps its shape. So that's how the arrangement of particles exist in a solid. So I think that's all pretty clear, hopefully. Okay, so that's the first state of matter. Now, when we cover changes of state next week, we'll ask the question, well, what happens if you put more and more energy into a solid? Well, the particles will vibrate more and more until you get to the point where the particles will actually start to be able to shift position. They've got so much energy they can break their bonds or loosen their bonds, and they can change their position relative to each other. So that's when a solid melts and becomes a liquid. So demonstration I've got here, okay, is a glass of my wife's baking beads, which represents a liquid. So if you think about each baking bead as being one atom, of course atoms are incredibly tiny, but we won't be able to see them. If you think of each one as each baking bead as an atom, you can see that just like the solid, they're very closely packed together. Okay. First of all, liquids are dense. They're generally slightly less dense than their solid form, but there are exceptions to that. When water turns into ice, ice is actually slightly less dense, even though it's a solid, than the liquid form of water, at least at 0 degrees centigrade. So that's why ice floats on water. Okay, but generally speaking, liquids are slightly less dense. But overall, there's not much difference between the density of particles in a liquid and the density of particles in a solid. The difference is between a liquid and a solid is that these particles are no longer in a fixed position. Okay, you can see immediately that they're all in sort of random positions, but also they can change position. Okay, I'll put my fingers in here. You can move the particles around. They're not bonded in a fixed pattern like they were in the solid. Okay, there's not a regular arrangement of particles. The particles can slide past each other. They can change places. Okay, and they regularly do so. So properties of a liquid is that a liquid will flow. Okay, it will flow and fill up a container from the bottom of the container upwards. So if I bring an empty glass here, I can pour my liquid into another glass, and you can see that the liquid will flow and fill up the bottom of the container. Okay, it won't expand beyond its surface. Okay, we'll talk about what happens then in a minute. But the liquid will flow and it will fill up the bottom of the container. Liquids can't be compressed because the particles are already touching each other. They're already close together. They can still feel each other's attractive pull. Okay, they're still bonded together, but they've got so much energy that they can actually change position relative to each other. Okay, but the particles are still so close together that the liquid is dense, and you can't compress a liquid because you can't push. I couldn't push these beads any closer together than they already are. So those are the properties of a liquid. And as you're aware, the third state of matter is a gas. So what's happening with a gas? Okay, well, here I've got another jug, which I've put some baking beads in at the bottom. And imagine that this is a liquid, and we put a flame underneath and we start heating the liquid up. Well, the particles are going to move about much more rapidly as you put more and more energy in. They're going to gain kinetic energy. So the average kinetic energy of the particles will go up. Another way of saying that is the temperature of the liquid will increase. So the particles will be moving faster. Eventually, you'll get to a point where the particles are moving so fast that the bonds that are holding them together, as you can see here, are no longer strong enough, and that the particles will fly apart from each other. Essentially, they'll escape from each other, and they'll fly off in a straight line until they hit the side of the container, and then they'll bounce off the side of the container. At that point, that's when a liquid has changed state into a gas. So best demonstration I can do for a gas, I suppose, is to shake this rather rapidly and hope that the cling film I put on the top doesn't break. So, a bit noisy, but that was what was happening to the particles in a gas. Okay, they're flying in straight lines until they hit the side of the container, then they bounce off. They don't often interact with each other because they're very far apart compared to the particles in a liquid or a solid. So properties of a gas is that a gas will actually expand and fill up the container that the gas is in. So, you know, going back to this again, if we turn, at the moment it's cooled down, it's a liquid again. If we turn this back into a gas, the gas would expand and fill the entire volume of the container. Unlike a liquid which flows to the bottom of the container, the gas will expand and fill out the entire volume of the container. The other obvious property as well is that a gas is much less dense than both a liquid or a solid, okay? Hundreds or thousands of times less dense than a liquid or a solid. So very low density, particles very far apart, moving very fast in straight lines, and the gas will expand to fill the container. The other difference as well, of course, is that because there's large gaps between the particles in a gas, is you can compress a gas. Okay, you can squash a gas or you can expand a gas. So you can actually change the volume of a gas and change its density, which you can't do really with a liquid or a solid. So that's it really. That's an overview of what I want you to learn about this week. Or for most of you, it will be reminding yourself because you've probably done it in chemistry before. The states of matter, solid, liquid and gas. What are the properties of the particles and how do those properties lead to the bulk properties that we see of solids, liquids and gases? And then after half term, we'll look at changes of state. Okay, so there will be a few notes for you to copy down into your textbook or folder or whatever you've got. Incidentally, I know we've had a few emails about exercise books and some students are running out of exercise books. Unfortunately, with the COVID-19, it is impossible for us to send out new exercise books or even have a stock of them in school that you could come in and collect. We just can't do that. There's no practical way of doing it. So the only solution would be if you can convince your parents to go online and order yourself some exercise books. They are incredibly cheap. I think you can buy, packs of 10 for a few quid or something like that. So they are really cheap. So I would recommend that if you are running out of paper exercise book, you do go and buy yourself a new exercise book. So that's it. There'll be some notes. There'll be a little homework sheet. I'm going to put a deadline. I was originally going to put a deadline of Friday night, but we're on Thursday at the moment. So I'm going to extend that a little bit to Sunday. But if you want to get it done before the weekend, obviously try and do it tomorrow. So there'll be a little homework sheet. And next week, or I should say the week after half term, I'm going to try and schedule a Zoom lesson with you guys, so that we can talk through a few things face to face. And thank you for the students who did come on the Zoom lesson last Friday. Okay, that's it. Thank you very much. We'll see you soon.